Hi, in this video, we're going to learn how to integrate using U-substitution. And to use U-substitution, first thing we need to do is to identify which term has the highest exponent. So in this case, the x cubed does, right? So once you identify which one has the highest exponent, we're gonna set it equals to u. So we're gonna have u equals to x cubed plus 1. The next thing will be to take the derivative of that term. So the derivative u will be du 3x squared dx. All right. So now, if you notice that we have an x squared dx, we have an x squared and a dx right there. We don't have the 3. However, if we divide by 3 here and divide by 3 right there, then we're going to have du over 3. It's equals to x squared dx. So now this matches these two guys. Okay, so now we can substitute du over 3 for x squared dx. Okay, so once we do that, we're going to end up with the square root of u times du over 3. Then what we can do now, it's we can factor out the 3 since it's a constant. So we factor out the 3 out of the integral. So we're going to have the integral of u, square root of u, times du. And if you remember that the square root is the same as to the power of 1/2, so we can just rewrite it as the integral of u to the 1/2, okay, times the respect to du. And at this point, it's easy to integrate. We just essentially add 1 plus 1, which is 2 over 2. 2 over 2 is 1. And then, so now we're going to have 1/3 u to the 3 halves. And then remember, when the power that you add is the one that you're going to divide with by. So then you're going to have times 2 over 3. Okay. Then you add your constant plus c. So this constant, once you get to differential equations, you spend a lot of time of that course solving for the value of c. Okay, so now we simplify a little bit here. So we have 2, 3 times 3 is 9, times, well, we said that our value for u was x cubed plus 1. So x cubed plus 1 to the 3/2 power. And of course, don't forget your plus c, because your professor will probably charge you a point for that c. Okay, so for this particular example, this will be our answer. Would be 2 over 9 here. Now, if we try a different one, let's go ahead and try the integral of x over x squared plus 1 dx. Okay. So which term do you think it would be your u? Well, if you said that x squared plus 1 was u, then you are on the right track. Okay, so you have x squared plus 1. That's because when you take the derivative, you can get rid of this guy. So you have du is equals to 2x dx. Now we do the same. We can divide by 2 here. We can divide by 2 there. This 2 essentially cancels out. We can simplify a little bit here. X dx. So now you see that this matches that. So du over 2 equals x dx. So with that being said, we can rewrite this guy as 1 over u times du over 2. And since 2 is a constant, then we can just factor out. You have 1 over u du. And if you remember that the integral of 1 over u, or 1 over x, it's equals to the ln of x, okay? And that's just a property. So if now we have a u here, so the integral of this guy would be the natural log of u plus c. So at this point, we can just go ahead and plug in our values for u, which is x squared plus 1. So we have 1/2 ln of x squared plus 1 plus c. So that will be the answer for this problem. So this will be it. So real quick, first thing you need to do is to identify which one is your u, and that's usually the highest exponent. Once you identify, then you take the derivative and simplify. Okay, well, if you have any questions, please let me know in the comments below. Hope you have a nice day.